Okay, so welcome to another deep dive today, and we're going to be looking at SQL interview prep.
Right,
So this is
yeah.
going to be, I think, a fun one. We've got a whole collection of common SQL interview questions and scenario-based problems with really good detailed explanations of how to, you know, answer them successfully.
Yeah.
And I'm excited to kind of walk through this stuff and, yeah, just kind of unpack,
hmm
what they're really looking for in these interviews when they're asking you SQL questions.
Right. Yeah. It's not just about like memorizing the answers or anything like that. It's about like, getting the logic behind it.
Yeah,
Like
exactly.
understanding what's actually going on when you write in SQL query.
Absolutely. And I think the explanations that we're going to go through today are really going to help with
Oh,
that.
mhm.
Okay, so you're going to encounter questions in these interviews that'll ask about the difference between where and having.
Right.
Can you
Mhm.
explain a little bit about how those work?
Sure. So, both where and having are used to filter data,
Yeah.
but the main difference is kind of when they happen in the query. So the where clause is applied first, and it filters rows based on a specific condition before any grouping happens.
Right.
So, for example, if you want to find all employees who earn more than $50,000, you would use a where clause to exclude anyone who earns less than that.
Got it. So it's like the initial kind of filter of the data,
Right, exactly.
and the having comes later.
Yeah, so having is used to filter groups of rows after they've been aggregated using a group by clause.
Okay, so you group by Y to get like a count of something or an average of something, and then the having is applied to the result of that.
Exactly, yeah.
Done.
So, for example, if you want to find all departments with an average salary greater than, say, $60,000,
Okay.
you would first group the employees by department using group by way, and then use a having clause to filter those groups based on the average salary.
I see. I see.
So, yeah, where filters individual records, and having filters the results of the group by.
Got it. So for our listener out there, where is like the initial filter?
Right.
It happens first, it filters individual records. Having happens later after you've done an aggregation like
Mhm.
a count or an average, and you filter the results of that.
Exactly.
Okay, cool. Another frequent topic that you'll see in SQL interviews is how to identify duplicate records.
Yeah.
So, data can be messy, they can be duplicates. What's the typical way in SQL to identify those?
So the typical way to identify duplicate records is to use a query that groups rows by the column where you suspect duplicates exist,
Okay.
and then uses the countout function to count the number of occurrences of each value,
Okay.
and then finally filters the results to show only the values that appear more than once.
Got it.
So the query would look something like this. You would select the column name and then count from the table name group by the column name, and then having count greater than 1.
Got it. So it groups by the column, counts how many times each value appears in that column, and then the having says, okay, only show me the ones where it appears more than once,
Exactly.
which means it's a duplicate.
Right.
Okay, cool. Let's move on to joining tables.
Okay.
Um, because a lot of times you're not just dealing with one table.
Mhm.
You've got data in multiple tables, and you need to join them together.
Right.
Um, so one of the basic things to understand is a difference between an inner join and a left join.
Yeah.
Can you kind of explain the basic difference there?
Sure. So, an inner join returns only the rows where there is a match in both tables based on the join condition.
Okay.
So, for example, if we have a table of employees and a table of departments,
Right.
and we join them based on the department ID, an inner join will only return the employees who are in a department that exists in the department table.
So it's kind of like the intersection
Yeah, exactly.
of those two tables, like the records that appear in both.
Right. And a left join, on the other hand, returns all the rows from the left table and the matching rows from the right table.
Okay.
If there's no match in the right table, it returns null for the columns from the right table.
So it's everything in that left table and then any matches from the right table.
Right, exactly.
Okay.
So if we use the same example with the employees and departments,
Right.
a left join would return all employees, even if they don't have a corresponding department.
Got it. Got it. Okay. Um, Another classic question that comes up in these interviews is how to find the second highest salary.
Yeah.
So, you've got a table of salaries and they want to know, how would you find the second highest one? What's the typical SQL way to do that?
Yeah, so the typical way to find the second highest salary is to use a subquery.
Okay.
So the subquery finds the highest salary, and then the outer query finds the maximum salary that is less than the highest salary.
Got it.
So the query would look something like this. Select the max salary as second highest salary from the employees table, where the salary is less than, and then in parentheses you have the subquery select max salary from employees.
Okay, so that subquery in parentheses, that's getting the highest salary.
Right.
And then the outer query is saying, okay, of all the salaries that are less than that highest salary, what's the maximum?
Exactly.
And that would be the second highest. Okay, cool. Makes sense. Let's talk about common table expressions,
Okay.
or CTEs.
Yeah.
These are basically a way to improve the readability and organization of your SQL queries. Can you kind of unpack that a little bit more?
Sure. So a CTE is basically a temporary named result set
Okay,
that you define within the scope of a single query.
got it.
So it's kind of like creating a temporary view
Okay,
that you can then reference later in your main query.
Okay.
So this helps to break down complex queries into smaller, more manageable chunks,
right.
and also to avoid repetition.
Got it.
So for example, if you have a complex query that involves calculating multiple aggregates,
Okay.
you could define those aggregates as CTEs and then reference them in the final select statement.
Okay, I see. So instead of having all those aggregates right there in the select statement,
Right.
you kind of break them out, give them names, and then you can reference them by name in the select.
Exactly.
Cool. Okay, so that helps with readability and organization. Makes sense.
Mm-hmm.
How about calculating running totals? How do we do that in SQL?
So to calculate running totals in SQL, you can use the SUM function along with the over clause and an order by clause within the over clause.
Okay.
So the order by y clause specifies the order in which the running total is calculated.
Okay.
So for example, if you have a table of orders with an order date and a revenue column,
Right.
you can calculate the running total of revenue by using a query like this. Select the order date, the revenue, and then ACOM revenue over, and then in parentheses order by order date, and then give that an alias of running total, and then from the orders table.
Okay, so the SEM revenue over,
Yeah.
and then order by order date that's calculating the running total
Exactly.
as it goes down.
Right.
Okay, got it. Let's talk about rank and dense rank.
Okay.
They both assign ranks to rows in a result set,
Yeah.
but there's a subtle difference between them. How do they actually work?
Right. So both rank and dense rank are used to assign ranks to rows based on a specific order.
Okay.
But the difference is in how they handle ties. So rank assigns the same rank to all tied rows, but then skips the subsequent ranks.
Okay.
So for example, if two rows are tied for first place, they will both have rank 1.
Okay.
But the next row will have rank 3.
Got it.
Dense rank, on the other hand, assigns the same rank to tied rows,
Okay.
but it does not skip ranks. So
Right.
the next row after the tied rows will have rank 2.
Got it.
So essentially, denser rank ensures that there are no gaps in the ranking.
Right. So if there's a tie, the next one just picks up where it left off.
Exactly.
With dense rank.
You're right.
Okay, cool. So, a classic interview problem that comes up is how to find the top N items within each group. So, for example, the top 3 highest paid employees in each department.
Right.
So how would you typically go about doing that in SQL?
So to find the top N items within each group, you can use the rank function in conjunction with the partition by clause.
Okay.
So the partition by clause divides the rows into partitions based on the specified column. And the rank function then assigns a rank to each row within each partition based on a specific order.
Oh, wow.
So for example, to find the top 3 highest paid employees in each department, you would first partition the employees table by department,
Right.
and then rank the employees within each department by salary in descending order.
Okay.
And then finally, you would filter the results to show only the employees with a rank less than or equal to 3.
Got it.
The query would look something like this. You would select the employee's name, department, and salary from a subquery where you select the name, department, salary, and then calculate the rank. Over partition by the department and order by the salary in descending order, giving that an alias of salary rank, and then from the employees table.
Okay.
And then the outer query would say where the salary rank is less than or equal to 3.
Got it. That makes sense. So partitions by department ranks all the salaries within each department, and then the outer query just filters to say, okay, I only want the ones that are ranked 1, 2, or 3.
Exactly.
Yeah. Okay. Very cool. How about calculating the difference between each employee's salary and the average salary for their department?
Okay, so to calculate the difference between each employee's salary and the average salary for their department, you can use the AVG function along with the over clause and the partition by clause.
Okay.
So the partition by clause divides the rows into partitions based on the department.
Okay.
And then the AVG function calculates the average salary for each department.
Got it.
And then you can subtract the employee's salary from the average salary to get the difference.
I see.
So the query would look something like this.
Yeah.
You select the employee's name, department, salary, and then you calculate the salary minus the AVG salary over partition by the department.
Okay.
And then you give that an alias of salary diff, and then from the employees table.
I see. So it's calculating the average salary for each department, but it's doing it kind of like in line with the original records.
Right.
So it's not collapsing the data down. It's keeping all the original records, and then it can compare each individual record to the average for their group.
Exactly.
Yeah. Cool. Cool. Okay. How about dividing data into quantiles? So, for example, if we wanted to divide our employees into salary quartiles.
Right. So to divide data into quantiles, you can use the entile function.
Okay.
The entile function takes an argument that specifies the number of quantiles you want.
Okay.
And it assigns a quantile number to each row based on its position within the ordered data. So, for
Okay.
example, to divide employees into quartiles based on salary.
Right.
You would use a query like this. You select the employee's name, salary, and then entile 4 over by the salary in descending order, giving that an alias of quartile, and then from the employees table.
So that entile 4, that's dividing into 4 groups.
Exactly.
Yeah.
Okay.
Which would be quartiles.
Got it. Got it. How about calculating the percentage of total revenue that each individual order contributes? Okay, so to calculate the percentage of total revenue that each order contributes, you can use the SUM function along with the over clause.
Okay.
But this time the over clause will be empty.
Okay.
So this will calculate the total revenue for all orders.
Got it.
And then you can divide each order's revenue by the total revenue and multiply by 100 to get the percentage.
Okay.
So the query would look something like this. You would select the order, the revenue, and then you calculate the revenue divided by the SUM revenue over with nothing in the parentheses.
Okay.
And then you multiply that by 100, giving it an alias of revenue percentage, and then from the orders table.
Got it. So that SEM revenue over
Yeah.
with nothing in the parentheses, it's getting the total revenue for all of the orders.
Exactly.
And then it's just dividing each order's revenue by that total to get the percentage.
Right. Mm-hmm.
Cool.
Mm.
This is a fun one. How about identifying relationships between rows within the same table?
Okay.
So, for example, if we wanted to find all the employees who earn a higher salary than their manager.
Right. So to do this, you would need to join the table to itself.
Okay.
This is called a self-join.
Okay.
So essentially, you create two aliases for the same table,
Right.
one representing the employee and one representing the manager.
Got it.
And then you join them based on the manager ID column.
Okay.
And then you can filter the results to only include the rows where the employee salary is greater than the manager's salary.
Got it.
So the query would look something like this. You would select e.name as the employee name, e.salary as the employee salary, and then m.name as the manager name, and m.salary as the manager salary from the employees table. And you're going to give it an alias of e.
Okay.
And then you're going to join the employees table again and give it an alias of m this time.
Okay.
And then the join condition is going to be on an e.managered, m.employed.
Okay.
And then the final part of the query is where e.salary is greater than m.salary.
Got it. So you're joining the employees table to itself, basically. And then that where clause is making sure that you only get the records where the employee salary is higher than the manager salary.
Exactly.
Okay, cool. Let's try combining some of these concepts.
Okay.
How would we go about calculating the cumulative percentage of total revenue as we go through the orders?
Right. So to calculate the cumulative percentage of total revenue, you would first calculate the running total of revenue for each order
Okay.
using the SUM function and the over clause.
Okay.
And then you would divide that running total by the total revenue for all orders,
Right.
which you can also get using the SUM function and an empty over clause.
Okay.
And then multiply it by 100 to get the percentage.
Okay.
So the query would look something like this. You would select the order, the revenue, and then you would calculate the SUM revenue over, and then in parentheses, order by the ordered,
Okay.
close parentheses,
Right.
and then divide that by the SUM revenue over empty parentheses, and then multiply by 100, giving it an alias of cumulative percentage, and then from the orders table.
Okay, so that first part, the SEM revenue over order by order, that's calculating the running total.
Exactly.
And then it's dividing that running total by the total revenue
Yeah.
for all the orders
Yeah,
to get
yeah.
the cumulative percentage as you go.
Exactly, yeah.
Okay, very cool. Let's move into a more advanced concept. How about calculating a moving average?
Okay.
So like, let's say we wanted to calculate the moving average of revenue over the last 3 months. How would we do that in SQL?
Right. So to calculate a moving average in SQL, you can use the AVG function along with the over clause and the rows between clause.
Okay.
So the rows between clause specifies the window of rows to include in the average calculation.
Yeah.
So for example, to calculate the moving average of revenue over the last 3 months, you could use a query like this. Select the order date, the revenue, and then you calculate the AVG revenue over, and then in parentheses, order by the order date, rows between 2 preceding and current row, giving that an alias of moving average. And then from the orders table.
Okay, so let me make sure I understand. So the AVG revenue is obvious. That's getting the average. But then the over, order by order day, rows between 2 preceding and current row. What's that part doing?
Right. So the rows between clause specifies the window of rows.
Okay.
So in this case, we're saying that we want to include the current row
Okay.
and the 2 preceding rows.
Got it.
In the average calculation.
Okay, so as it goes down, it's taking the current row and the 2 rows before it.
Exactly.
And calculating the average.
Right.
Okay, cool. And this would be very similar to the other top-end problems that we've done.
Yeah.
But how would we go about finding the top 5 products by sales within each product category?
Right. So to find the top 5 products by sales within each category, you would again use the rank function and the partition by clause.
Okay.
So you would partition the products table by category.
Right.
And then rank the products within each category by sales in descending order.
Okay.
And then finally, you would filter the results to show only the products with a rank less than or equal to 5. The query would look something like this. You select the product name, category, and sales from, and then a subquery where you select the product name, the category, the sales, and you calculate the rank over partition by the category order, by the sales in descending order, giving that an alias of sales rank from the products table. And then the outer query is where the sales rank is less than or equal to 5.
Got it. So it's the same kind of pattern
Exactly.
as the top-end employees per department.
Right.
Just with different tables and different columns.
Exactly.
Okay, cool. We also had some scenario-based questions in the prep material that we were looking at, which I thought were really cool.
Yeah.
Because they really show how these concepts apply to real-world situations.
Right.
Like, for example, we saw one where they were asking to rank customers based on their total spending within each region.
Right.
Which is basically, using rank and partition.
Exactly.
And then calculating the month-over-month change in sales revenue.
Yeah.
That was a really cool one, too, because it used window functions to compare the values from one month to the previous month.
Right.
And then finding the most recently active users in each subscription tier.
Yeah.
That was a good one. They used order by and limit.
Exactly. Yeah.
So it's really cool to see how these core SQL concepts that we've been talking about really do apply to those, day-to-day data analysis type questions
Absolutely.
that you might get in a real job.
Yeah, these scenario-based questions are really designed to test your ability to apply these SQL concepts to real-world problems.
Yeah, exactly. So, we've covered a lot of ground here.
We have.
We talked about, the basic difference between where and having.
Right.
We talked about joins. We talked about subqueries.
Yeah.
We talked about CTEs, window functions, all kinds of cool stuff.
Yeah, a lot of good stuff.
So hopefully our listener out there is feeling a little bit more prepared
I hope so.
for those SQL interview questions.
Yeah.
So I guess as a final thought, what would you say to someone who's out there preparing for these interviews?
I would say that the best way to prepare is to practice.
Yeah.
Just keep writing SQL queries.
Right.
Try to solve different problems.
Right.
And also, don't be afraid to look things up.
Yeah, absolutely.
There's a lot of great resources out there.
Tons of stuff online. Yeah.
And, nobody expects you to memorize everything.
Right.
So just be familiar with the concepts and, be able to apply them to different situations.
I think that's really what these examples today have shown is, once you understand the concepts,
Right.
you can apply them to all different kinds of problems.
Exactly.
Yeah, great advice. Practice, practice, practice.
Yes.
Well, this has been fun.
Yeah, it is.
I always love a good SQL deep dive.
Me too.
So for our listener out there, good luck with those interviews.
Yes. Good luck.
And we'll catch you on the next deep dive.
All right. See you, Ben.
Bye.